And again, another way to interpret this, if we were to take 100 samples of size 50, found the sample mean, and then constructed the confidence interval, we would expect 95 of those 100 intervals to contain the true value of mu. So some of them we'd expect about 5 of them to not actually contain the value of mu. Now again, we don't know what mu is, but that's the theory behind this, is we expect 95% of our intervals that we construct, when we take a sample of 50, we expect 95 out of those 100 to contain the true value of mu, the population mean. Okay, for a 98% confidence interval, now I messed this up when I first did the answer key because I was thinking 99%, so I tricked myself on this. Okay, but 98% confidence interval has a z star value of 2.33, and again, that's from taking the 2% that's left over, splitting between the two ends. Okay, so like here, we had 99% up here, so 98%, you'd have 0.01 on each end. And when you look that up in your table, you get 2.33. So I suggest you go and do that just to make sure that you can do it. And then times your sigma over square root of n, and we get this interval here. Okay, so we're 98% confident that that our interval 21.892 to 23.374 contains the true value of the population mean mu. Okay, and again, notice what happened here is that 22.633 is going to be the center of each of those confidence intervals. And notice here, with 98% confidence, we allow more values in. Okay, 21.892 is less than 22.009, and 23.374 is a little bit higher than 23.257. So our 98% confidence interval allowed more values in to our interval. Okay, and that goes on with the idea that as our confidence level increases, our interval has to get wider. Just because to be more confident, we have to allow more values in. Okay, on the next page, we're going to look at finding a minimum sample size. Okay, so these two examples are pretty quick. Okay, what we're going to do is now suppose you want to construct a confidence interval and you want to know what sample size should you take. Okay, so what is the minimum sample size you need in order to get a certain margin of error given a standard deviation, okay, and a confidence level. Okay, so if you take our margin of error formula, E equals z star times sigma square root of n, and you solve it for n. Okay, so one way to rewrite this is E equals z star times sigma over the square root of n. Remember, that's like z star over 1. When you multiply fractions, you go straight across. Okay, and then if you treat this as a proportion, cross multiply. So essentially, you can flip flop e in the square root of n. So the square root of n equals z star times sigma over the margin of error. And then to undo the square root of n here, you square both sides. So n, or sample size, would equal the quantity z star times sigma over the margin of error squared. Okay, so that'll give you the minimum sample size you need to estimate what mu is. So that means when you read a question, if you want to estimate mu and you want to find a minimum sample size, you're trying to find what n is now, you need to know your z star, which comes from your confidence level, sigma, which is your population standard deviation, and you need to know what margin of error are they looking at. So how much error do they want in their interval? Okay, so number 3, an admission director wants to estimate the mean age of all students enrolled at a college. The estimate must be within 0.5 years of the population mean. So to be within 0.5 years of the population mean, they're telling you that 0.5 years is the margin of error. Assume the population of age is normally distributed, a standard deviation of 3 years. So that's 3 is your standard deviation for the population. And then we want a minimum sample size to construct a 90% confidence interval. So your C percent confidence, so your 90% confidence interval. Well, what Z star value goes with a confidence level of 90%? Okay, that was a value of 1.645. Okay, so the arithmetic on that, just plug those into the formula. And again, I already have that worked out. Okay, so I'll show you here. Okay, nothing for me to really explain there other than when you plug these values into your calculator, do not round until the final step. And when you round, you're always going to round up to the next number. So here, when you put those values in, you get 97.4169. And we're always going to round up to the next value, in this case, 98. That's essentially saying that you need 97.4 people in your population. I'm sorry, in your sample to estimate the population mean. So you don't want to sample 97 because you haven't gone far enough. So you have to go up to the next person, because these will be whole numbers in your sample size. Okay, so you round up to 98. Okay, but again, do not round until the final step. So as you're plugging the numbers into the formula, okay, do not round until the very end, which is when you round up. Okay. Okay, nothing crazy there to explain. Number 4, same type of question. A diet guru wants to estimate the average amount of weight all female participants lose on their diet. How many female participants must the guru sample? Okay, so how many must they sample? That means you're trying to find N. Okay, so we're trying to find our sample size to estimate the mean weight loss to be within 2 pounds. So to be within 2 pounds, that's your margin of error. Use a population standard deviation of 5.5 pounds. Okay, so that's sigma. And we're going to do 2 different ones, one for 95% confidence and one for 99% confidence. Okay, so again, it's just plug it into your formula. And again, for the sake of time here, okay, I'm just going to show you this plug and chug into the formulas and the final answers. Okay, on the first one there with the 95% confidence, remember that was a z-star of 1.96. And with n equals 29.05, even though that's very close to 29, always round up to the next number, to the next whole number, okay, or next integer, 30. Okay, your 99% confidence level had a z-star of 2.575. So plug those values in. And again, don't round until you round up in the final step of 51. Okay, so that takes care of the more formal version of some examples with confidence intervals.